Today we are going to discuss visual classification of soils, and the reference of this as per ASTM, that is ASTM D2488. Significance. The first step in any geotechnical engineering project is to identify and describe the subsoil condition. For example, as soon as a ground is identified as gravel, an engineer can immediately form some ideas on the nature of problems that might be encountered in a terraining project. In contrast, a soft clay ground is expected to lead the other types of design and construction considerations. Therefore, it is useful to have a systematic procedure for identification of soils even in the planning stages of project. Soils can be classified into two general categories. Number one, coarse-grained soils, and number two, fine-grained soils. Examples of coarse-grained soils are gravels and sands. Examples of fine-grained soils are silts and clays. Procedures for visual identification. These two general types of soils are described in the following section. Identification procedure. Identify the color, for example, brown, gray, brownish gray, odor, if any, and texture, coarse or fine-grained of soil. Identify the major soil constituent that's greater than 50% by weight using table 1 as coarse gravel, fine gravel, coarse sand, medium sand, fine sand, or fines. So when you will be able to see the table 1, so these things will be cleared. Estimate percentages of all other soil constituents using table 1, and the following terms will be used. Trace when you are having 0 to 10% by weight, little 10 to 20%, some 20 to 30%, and 30 to 50%. So here you would find some example. For example, trace, fine gravel, little silt, some clay. So in this way, we'll be using these terms. Next is, if the major soil constituent is sand or gravel, identify particle distribution. Describe as well-graded or poorly graded. Well-graded soil consists of particle sizes over a wide range. So wide range of particle sizes is present. Poorly graded soil consists of particles which are all about the same size. Or you can say there is no good representation of particles of various sizes. Identify particle shape: angular, subangular, rounded, subrounded, using figure 1 and table 2. If the major soil constituents are fines, perform the following test. Dry strength test. Mold a sample into 1/8" size ball and let it dry. Test the strength of the dry sample by crushing it between the fingers. Describe the strength as none, low, medium, high, or very high depending on the results of the test as shown in table 3A. Dilatancy test. Make a sample of soft, puffy consistency in your palm, then observe the reaction during shaking, squeezing by closing hand, and vigorous tapping. The reaction is rapid, slow, or none according to the test results given in table 3b. During dilatancy test, vibration densifies the silt and water appears on the surface. Now on squeezing, shear stresses are applied on the densified silt. The dense silt has a tendency for volume increase or dilatancy due to shear stresses. So the water disappears from the surface. Moreover, silty soil has a high permeability, so the water moves quickly. Whereas in clay, we see no change, no shiny surface. In other words, no reaction. Plasticity or toughness test. Roll the sample into a thread about 1/8 in diameter. Fold the thread and re-roll it repeatedly until the thread crumbles at a diameter of 1/8 inch. Note: the pressure required to roll the thread when it is near crumbling. And the next thing that you will have to note is whether it can support its own weight. Next is whether it can be molded back into a coherent mass. And the next thing, whether it is tough. During kneading, describe the plasticity and toughness according to the criteria in table 3c and 3d. A low to medium toughness and non-plastic to low plasticity is the indication that the soil is silty, otherwise the soil is clay. Based on dry strength, dilatancy, and toughness, determine soil symbol based on table 4. Next is identify moisture condition: dry, moist, wet, or saturated using table 5. Record visual classification of the soil in the following order: color, major constituent, minor constituents, particle distribution and particle shape if major constituent is coarse-grained, plasticity if major constituent is fine-grained, moisture content, soil symbol if major constituent is fine-grained. Examples of coarse-grained soils: here you would find soil 1, brown fine gravel, some coarse to fine sand, trace silt, trace clay, well graded, angular, dry. So in this way we can describe the soil. Similarly, if you have got this particular soil, so the description is gray coarse sand, trace medium to fine sand, some silt, trace clay, poorly graded, rounded, saturated. And here you would find the examples of fine grained soils. Soil A, brown lean clay, trace coarse to fine sand, medium plasticity, moist, and look at the symbol Cl. And then here the soil B means gray clay silt, trace fine sand, non-plastic, saturated. So the symbol is Ml. So in this way, we can give the symbols to the soil, fine-grained soils. Now here you would find the tables and the figure that we have discussed on the previous slides. So here the table 1, grain size distribution. So you can see boulder, cobbles, coarse gravel, fine gravel, coarse sand, medium sand, fine sand, and fines. And here you can see the size limits are mentioned for these soil constituents. And here familiar examples are given. That means the boulder larger than basketball, cobbles, grapefruit, and so on. So this is table 1. This is the figure 1, where you can see the shape of coarse-grained soil particles: rounded, sub-rounded, angular, and subangular. And this is table 2. Criteria for describing shape of coarse-grained soil particles: angular, subangular, subrounded, rounded. So you would find the criterias. Angular means particles have sharp edges and relatively plain sides with unpolished surfaces. Subangular particles are similar to angular description but have rounded edges. So look at this one. Subrounded particles have nearly plain sides but have all rounded corners and edges. Well-rounded corners and edges. Rounded particles have smoothly curved sides and no edges. So in this way, you could be able to identify these different shapes visually. This is table 3A, criteria for describing dry strength: none, low, medium, high, very high. So what does this mean, none? The dry specimen ball crumbles into powder with the slightest handling pressure. Low means the dry specimen crumbles into powder with some pressure from fingers. Medium, the dry specimen breaks into pieces or crumbles with moderate finger pressure. High, the dry specimen cannot be broken. So look at that. With finger pressure, specimen will break into pieces between thumb and a hard surface. And very high, the dry specimen cannot be broken between the thumb and a hard surface. So in this way, you could be able to comment on the dry strength. This is table 3B, criteria for describing dilatancy of a soil sample: none, slow, rapid. So what is the meaning of none? There is no visible change in the soil samples. Slow, water slowly appears and remains on the surface during shaking, or water slowly disappears upon squeezing. Rapid, water quickly appears on the surface during shaking and quickly disappears upon squeezing. This is table 3C, criteria for describing soil plasticity: non-plastic, low, medium, and high. So a 1/8 inch thread cannot be rolled at any water content, so it means you have got the non-plastic soil. Low plasticity is there, the thread is difficult to roll and a cohesive mass cannot be formed when drier than the plastic limit. Medium, the thread is easy to roll and little time is needed to reach the plastic limit. The thread cannot be re-rolled after the plastic limit is reached. The mass crumbles when it is drier than the plastic limit. And what does this mean? High, considerable time is needed rolling and kneading the sample to reach the plastic limit. The thread can be re-rolled and reworked several times before reaching the plastic limit. A mass can be formed when the sample is drier than the plastic limit. Well, this is table 3D, criteria for describing soil toughness: low, medium, and high, and the description is given for low. Only slight pressure is needed to roll the thread to the plastic limit. The thread and mass are weak and soft. Medium, moderate pressure is needed to roll the thread to near the plastic limit. The thread and the mass have moderate stiffness. High, substantial pressure is needed to roll the thread to near the plastic limit. The thread and mass are very stiff. Here you would find the table 4, identification of inorganic fine-grained soils. So look at the symbols Ml, Cl, Mh, and Ch, and you are familiar with these symbols. Dry strength, none to low, medium to high, low to medium, high to very high for ml, cl, mh, oh, ch. Similarly, if you just look at the dilatancy, and for ml, slow to rapid, for cl, none to slow, and mh, none to slow, and ch, none. And the toughness criteria for ml, low or thread cannot be formed, for cl, medium toughness, for mh, low to medium, and high for ch. So here look at this note, ml means silt, cl means lean clay, low plasticity clay you can say, mh elastic soil or you can say highly plastic silt, ch fat clay or highly plastic clay. The term lean and fat may not be used in certain geographic regions. So by using this table is very useful, and based upon dry strength, dilatancy test results and the toughness, we could be able to identify the soil, ml, cl, mh and ch. Here the table 5, criteria for describing soil moisture condition: dry, moist, wet, saturated. Soil is dry, I mean to say when we will be using this term dry, in this case soil is dry to the touch, dusty, clear absence of moisture. Moist, soil is damp, slight moisture, soil may begin to retain molded form. Wet, soil is clearly wet, water is visible when sample is squeezed. And saturated, that it means here water is easily visible and drains freely from the sample. So in this way you could be able to get the idea about the moisture condition of the soil. Now in the following slides you would find some soils, and we will classify those soils visually, on the basis of visual judgment. So look at that, this is the soil. You can see the coin which is present over there, just to have some idea about the particle size. So here you can see the color brown, order none, and you can see the texture coarse, and the major soil constituent you can see it is written over here, and the minor soil constituents are also written. So gravel, that is the major constituent, and the minor soil constituents are sand, fines, and then look at the percentages, approximately percentages of these constituents: gravel, sand and fines. So you can see here the percentages are mentioned. Then comes for coarse-grained soil, the gradation, it seems well graded, that means the good representation of particles of various sizes, and the particle shape, the sub-rounded. So you can see here this one is not meant for this soil because this is coarse-grained soil. So this is the part which will be used for fine-grained soil. The moisture condition is mentioned over here. So ultimately you can see here the classification, and the description is written: brown, gravel, some sand, trace, fines, well graded, sub-rounded, dry, because the moisture condition is dry. Now look at this soil, this is soil B, and look at here the particle size is very small, and you can see here relatively small from the previous one, you can say. So here the color gray, order is there is no order, texture coarse, and the major soil constituents sand, and the minor and soil constituents are mentioned over here: gravel and fines, some gravel and some fines, and look at the percentages of different constituents. Sand, fine gravel and fines are written over here, and then you can see here the gradation. It's poorly graded, and the particle shape is also mentioned, that is rounded, and then moisture condition, that is dry. And look at the description which is given over here. You can see that the gray sand, little fine gravel, trace fines, poorly graded, rounded, dry. So you will have to use these terms over here for this soil. Now look at this particular soil. This is soil C, and look at that. Color is gray, order none, texture fine. You can say this fine grained because the particle size is very small. Major soil constituent, you can say the fines. Minor soil constituent, fine sand. And look at the percentages, approximate percentages of these constituent fines, 95%, and fine sand just 5%. Now obviously this part is not meant for this, because this one is meant for coarse grain. So this soil is fine grain, so obviously we'll be using this one. So look at this one, this part. So dry strength is high, dilatancy none, plasticity is mentioned over here, toughness, and the soil symbol, ultimately we are getting Cl, and the moisture condition moist. So in this way you can describe this in this